This is Jack Jackson. In this video, we're going to talk a little bit about antiderivatives and basic trigonometric functions, inverse trigonometric functions, and a couple of hyperbolic trigonometric functions. Before I do that, let's review very quickly how we have several different basic properties of derivatives, antiderivatives, and integrals. Everything here should be completely memorized. Okay, you should already have these properties of derivatives memorized, and they correspond to properties of antiderivatives. So the derivative of the sum is the sum of the derivatives, and the antiderivative of the sum is the sum of the antiderivatives. The derivative of a constant times a function is a constant times derivative function. So the antiderivative of a constant times a function is a constant times the antiderivative of that function. Now the product rule is more complicated. The derivative of f times g is f times g prime plus g times f prime. That's reversed by the integration by parts. The integral of u dv equals uv minus the integral of v du. The quotient rule is the derivative of f of x over g of x. That's the bottom times the derivative of the top minus the top times the derivative of the bottom over the bottom square. The chain rule is reversed by the technique of substitution. The derivative of constant is 0, so the antiderivative of 0 is a constant. The derivative of a linear function is a, that's that coefficient of x. And so the antiderivative of a constant is just a linear function with that slope a. The derivative of u to the n is n times u to the n minus 1 du over dx. So the antiderivative of u to the n is u to the n plus 1 times 1 over n plus 1 plus c. Okay? This works for everything except for n equals negative 1, in which case the antiderivative of u to the negative 1 is the logarithm of absolute value of u plus c, because we know the derivative of log of absolute value of u is 1 over u times the derivative of the u. And derivative of e to the u is just e to the u. So the antiderivative of the e to the u is e to the u. The derivative of b to the u is log of b times b to the u. And so the antiderivative of b to the u is 1 over log of b times b to the u. Now over here, if you've done a substitution, we need the du over dx. Here I'm assuming the substitution's already been done, so everything's in terms of u. And then the antiderivative here is actually not one single antiderivative, but an entire family of antiderivatives. So you always put that plus c. I've seen other people like to put c plus in the beginning rather than plus c at the back. I think the answers in Stewart's calculus book, when we do those things in WebAssign, have a tendency to put c plus at the beginning. But it doesn't matter whether you put c plus and then the function, or the function and then plus c. Same thing. Now all of these should be memorized. You really have to understand this. Now you have to also be careful of which direction you're going. For example, it's easy to get confused about, okay, is it the way where we subtract 1 from the power and multiply by the original power? Or is it the one where we add 1 to the power and divide by the new power? This side over here is taking a derivative, this side is taking an antiderivative. But you have to kind of do both when you're doing antiderivatives, because if you do a substitution, the part where you go from u to du is taking a derivative, that's using a rule on the left, whereas the part once you've done the substitution and you find the antiderivative, that might be using one of the rules on the right. Now, just as we have those rules, we certainly also have rules for trig functions. So again, here u is a function of x and c is our arbitrary constant called the constant of integration. So the derivative of sine of u is cosine of u. So the antiderivative of cosine u is sine u. The derivative of cosine u is minus sine of u, so the antiderivative of sine u is the opposite of cosine of u. The derivative of tangent u is secant square u, so the antiderivative of secant square u is tangent u. The derivative of secant u is secant u times tangent u, so the antiderivative of secant u times tangent u is secant of u. The derivative of cotangent u is minus cosecant square of u, and so the antiderivative of cosecant square of u is minus cotangent of u. And the derivative of cosecant of u is the opposite of cosecant of u times cotangent of u. So the antiderivative of cosecant of u times cotangent of u is the opposite of cosecant of u. Okay, some hyperbolic ones here. Just two basic ones. The derivative of sinh is cosh, so the antiderivative of cosh is sinh. The derivative of cosh is sinh, so the antiderivative of sinh is cosh. And let's not forget a couple of inverse trig functions here. The derivative of arc sine of u, that might be written as sine superscript negative 1, which would be read as the inverse sine of u. or just read it as the arc sine of u. So the derivative of the inverse sine of u, or derivative of arc sine of u, is 1 over square root of 1 minus u squared. So that means the antiderivative of 1 over the square root of 1 minus u squared with respect to u is the arc sine of u. The arc tangent of u, when you take a derivative, you get 1 over u squared plus 1. And so the antiderivative of 1 over u squared plus 1 is arc tangent of u. Some people would write this as 1 over 1 plus u squared. Switch the order here. It doesn't make any difference. Now, once again, it's extremely important that you memorize these basic facts. And you need to do whatever it takes to do that. You might just start by just writing them down several times. One thing that's pretty effective sometimes is to write out some flashcards and write, like on one side write d over dx of sine of u, and on the other side write cosine of u du over dx. Or write down on another card, say the antiderivative of cosine of u du, and then on the other side write sine of u plus c. And see if you can go through the cards either direction. And just work through these till you get better and better at it. And of course, one of the best ways you can get better at using these at knowing these properties is to also just to actually use them in problems. But it's very important that you know these basic rules. Now, next you'll see here 7 functions that are 7 problems, and I'm asking you to solve them. About half of them are family of antiderivative about a third of them roughly are find the family of antiderivatives. Another third is about a third is finding definite integral, and another couple of them are given the value of the derivative, giving the formula of the derivative and the value of the function at one point, an initial condition, find the function f of x. So those are the 3 basic kinds of problems that we have in this unit. So see if you can do all these. Please write down these formulas and problems. Try to work them on your own, and when you get them, come back and we can take a look at your solutions here. It's really important that when I ask you to pause these videos that you actually do this and try these yourself first. Even if you have to go to the point of maybe just doing one of them and checking it, then do the next one and check it. Or you might just try to do them all right now. We're actually going to stop the video here at this point, and after you've written these down, we'll come back in the next video and work these. Okay? So press pause if you need to write these down, and then when you're done, we'll go on to the next video.